Okay, so today what we're going to talk about is we're going to talk about solution sets to inequalities with two variables. When working with inequalities in one variable, which we saw in past lessons, we learned to graph the solution set on a number line. When working with inequalities with two variables, the solutions are also represented visually, but in two dimensions in the coordinate plane. So instead of on a number line for inequalities in two variables, we're going to have two dimensions because we have two variables, so that would be two dimensions. They want us to circle each ordered pair, x, y, that is a solution to the equation 4x minus y is less than 10. So I'm just going to start with this first one, 3, 2. So I have x is 3, y is 2. So I'm going to take this 4x minus y is less than or equal to 10. And wherever I see an x, I'm going to substitute in 3. Wherever I see a y, I'm going to substitute in 2. So I'll have 4 times 3 minus 2. And I'm going to see if that's greater than or equal to 10. 4 times 3 is 12. So I have 12 minus 2 is 10. So I get that 10 is less than or equal to 10, which is true. So I'm going to circle that one. Now let's go down to 5, 10. So x is going to be 5, y is going to be 10. So I'm going to have 4 times 5 minus 10 is less than or equal to 10. 5 times 4 is 20, minus 10 is 10. So again, I get 10 is less than or equal to 10. So I'll circle that one. Let's look at 2, 3. So wherever I see an x in this equation, I'm going to substitute in 2. Y is going to be 3. So I'll have 4 times 2 minus 3 is less than or equal to 10. 4 times 2 is 8, minus 3 is 5. So I get 5 is less than or equal to 10, which is true. So I circle that one. Now I have 0, negative 10. So x is going to be 0, y is going to be negative 10. So I have 4 times 0 minus a negative 10 is less than or equal to 10. 4 times 0 is 0, minus a negative 10 is plus 10. 0 plus 10 is 10. So I get 10 is less than or equal to 10. So that is a solution. Now let's go over to negative 1, negative 14. So x is going to be negative 1, y is going to be negative 14. I'll just go above. So here I'll have 4 times x is negative 1 minus y is negative 14. And I want to know if that's less than or equal to 10. 4 times negative 1 is negative 4. Minus a negative 14 is plus 4. So we'll have negative 4 plus 14. Negative 4 plus 14 is 10. So I get 10 is less than or equal to 10, which is true. So I circle that one. Now I have 3, 4 here. So if I look at this, I know that x is going to be equal to 3, y is going to be equal to 4. So if I look at this, I'm going to have 4 times 3 minus 4, and I want to know if that's less than or equal to 10. 4 times 3 is 12. 12 minus 4 is 8. So I get that 8 is less than or equal to 10. So I know that that is true. So then this is going to be another solution to our inequality. Then we have the point 0, 0. So let's plug in 0 for x, 0 for y. So I have 4 times 0 minus 0, and I want to know if that's less than or equal to 10. 4 times 0 is 0, minus 0 is 0, and I get that 0 is less than 10, and I know that's true, so that is a solution. Now we look at 6, 0 here. So I'm just going to, well actually let's just do this one first. 1, negative 6. So if I do 1, negative 6, I'll do it up here. So x is 1, y is negative 6, so I'm going to plug it in. 4 times 1 minus a negative 6, and I want to know if that's less than or equal to 10. 4 times 1 is 4, minus a negative 6 is plus 6, and I want to know if that's less than or equal to 10. And I get that 10 is less than or equal to 10, and that's true. So I circle that inequality. Okay. Next I'll do 6, 0. So I'll just do it down here. So I'll just draw this line. So I'm going to do 6, 0 right here. So I have 4 times 6 minus 0, and I want to know if that's less than or equal to 10. 6 times 4 is 24, minus 0 is less than 10. So I get 24 is less than or equal to 10, which is not true. So this one would not be true. So now let's look at this next one. 4, negative 1. I'll do that one right here. So I'm going to have 4 times 4 minus a negative 1, and I want to know if that's less than or equal to 10. 4 times 4 is 16, minus a negative 1 is plus 1, is less than or equal to 10, and I get that 17 is less than or equal to 10, which is not true. So that's not going to be a solution. So we have 1, 2, 3, 4, 5, 6, 7, 8 solutions altogether. And the only ones that aren't are those last two. They want us to plot each solution as a point x, y in the coordinate plane. So let's go through and let's label our coordinate plane now. So if we label our coordinate plane, I'm just going to go up by 2's. So I'm just going to go 2, 4, 6, 8, 10. And in the y's, doing the same thing. 2, 4, 6, 8, 10. Then I go down. Negative 2, negative 4, negative 6, negative 8, and then negative 10. Same thing here. Negative 2, negative 4, negative 6, negative 8, negative 10. And now I want to plot each one of these points. So let's just start with 3, 2. So I go over in the x3, up 2. I do 2, 3. So I go over 2, up 3. So I go negative 1, negative 14. So I have negative 1. Go down to about negative 14. So that's negative 10. So then I have to go a little bit off the graph here. So I'm at negative 1, negative 14. So 1, 2, 3, 4. So about there. 0, 0. 1, negative 6. 5, 10. So I have 5 up to 10. 0, negative 10. So 0 on the x, negative 10. Oops, actually 0 on the x, negative 10. Be down here. 3, 4. So I go over 3, up 4. And then I don't plot either of these because they're not part of our solutions. Okay? So, what we want to look at is part C. It says, how would you describe the location of the solutions in the coordinate plane? Well, in the coordinate plane, if you look at all these points, we can't really connect them with a line. So that's what we're going to write down. That our points don't fall on a line. There's not a specific line that we could draw that would connect all of those points together. But if we look at this, we have our x-axis, our y-axis. We want to know if there's some line that could be relatively close to all of these points. So let's move on to exercise 2. It goes along with exercise 1, but it shows it a little bit further in depth. They want us to discover as many solutions to the equation 4x minus y is less than or equal to 10 as possible. And organize your solutions by plotting each solution as a point x, y in the coordinate plane. So basically, what we have to look at is we have to pick an x and a y such that if we have 4x minus y, that's going to be less than or equal to 10. So let's just try the point 1, 1. So if we try the point 1, 1, so x is 1, y is 1, Let's see if that works. 4 times 1 minus 1 is less than or equal to 10. 4 times 1 is 4, minus 1 is 3, and that's less than 10. So this one works. Let me just pick another point. Let's just say 1, negative 3. Let's see if that works. So basically what we're doing is we're just doing a little bit of guess and check to see if it will work. So 1, negative 3. So I'm plugging in 1 for x, negative 3 for y, so it'll be minus negative 3, is less than or equal to 10. 4 times 1 is 4, minus a negative 3 would be 4 plus 3, which would be 7, and 7 is less than 10. So that's another one that will work. Okay? And we could pick as many other points as we want to. We just have to keep doing the guess and the check. Okay? So for part B, they want us to graph the line y is equal to 4x minus 10. So instead of using this graph, I'm going to use the graph that we already used in part A, because it's all the same thing. They want us to graph this line, 4x minus 10. Okay? So if we were graphing 4x minus 10, we know that if we wanted to graph this line, we need 2 points, because any 2 points will make a line. So let's just let x equal 0 and see what we get for y. So we have this line, y is equal to 4x minus 10. Okay? And then what we're going to do is we're going to substitute x is 0. So our first coordinate that we're going to plot x will be 0. Let's figure out what y would be. So we're going to set y is equal to 4 times 0 minus 10. 4 times 0 is 0, minus 10 is negative 10. So we're going to get negative 10. So y is equal to negative 10. So our first coordinate for that line is 0, negative 10. Now let's look for another coordinate where instead let's set y equal to 0. So I'm going to set y equal to 0 and see what x would be. So 0 is equal to 4x minus 10. So to get x by itself, I'm going to add 10. Add 10. So I get 10 is equal to 4x. And then on both sides, to get what x is, divide by 4. Divide by 4, I get x is equal to 2.5. So my other coordinate for this graph is going to be 2.5. 0 for x. Okay? So again, all I did down here was I substituted in 0 for y and then solved for x. So that my new coordinate would be 2.5, 0. So my first coordinate is 0, negative 10. My second coordinate is 2.5, 0. So now let's go back up and let's plot these 2 points. Okay? So 2.5, 0. So if I do 2.5, 0 would be about here. Okay? Let's do this in pen. So I'm going to do this in red pen just so we can see it. So we have 2.50, which would be right here. This point right there. And then we have the point 0, negative 10. So 0, negative 10 would be right here. If I were to go through and connect them with a straight edge, so I'm going to plot these points with a straight line. Okay, so now we graph this line, and this line is y is equal to 4x minus 10. Okay, so once I plot that point there, or plot that graph, or draw that graph, then what they want us to do is they want us to solve the inequality for y. So now I'll go back to that. So I'm just going to draw a line over here so I can, they want us to take this inequality, 4x minus y is less than 10, and solve it for y. So here, if we look at this, let's go through it. We have 4x minus y is less than or equal to 10. So what we're going to do here is let's solve for y. So subtract 4x, subtract 4x. We get negative y. is less than or equal to negative 4x plus 10. Now if we look at this, let's divide by negative 1, divide by negative 1. So we're going to get y. Remember, if we divide by negative here, since we're dividing by negative 1, we have to flip this inequality sign. Negative 4x divided by negative 1 is just 4x. Positive 10 minus, or divided by negative 1 is going to be a negative 10. So we get this inequality. Y is greater than 4x minus 10. So if we look at this, let's go back to this question up here, B. It says, what do you notice about the solution to the inequality 4x minus y is less than or equal to 10? And the graph of the line, y is equal to 4x minus 10. So let's go back to our graph up here. So if we look at our graph, here's our line, and all of our points all kind of either lie on this line or they lie above this line. So if we're drawing the solution set, so if we look at this, all of our solutions are either on this line or they're above this line in this area over here. So if we picked any point over in this area, it would be a solution to this inequality. 4x minus y is less than or equal to 10. So if I pick any point over here that's on the line or to the left of the line, it will be a solution to that inequality. So really, if we look at this for A, discover as many additional solutions of the equations 4x minus y is less than or equal to 10 as possible. We know that there is an infinite amount. Okay, because we can pick any point that's over above this line. So, let's complete the part D. It says, complete the following sentence. If an ordered pair is a solution to 4x minus y is less than or equal to 10, then it will be located either on or above the line y is equal to 4x minus 10. Okay? So, if we know that the solution can be on this line or above this line, we're going to shade above this line. So we can just shade everything right above this line. And if we pick any solution in the shaded area, that would be our solution to the inequality. Okay? So now what I'm going to do is I'm going to move on to exercise, for example, 1. So looking at this, we're going to deal with the dashed versus solid line. When graphing inequalities with two variables, we should either have a solid line or a dashed line. How we determine if we draw a dashed or solid line depends on if we have equality or not. So it says, use the chart below to determine if we draw a dashed line or a solid line. So if we have less than we don't have equality. So if we don't have equality, we're going to label a dashed line. And anytime it's less than, we're going to go below the line. If we have greater than, we don't have equality, so we're going to use a dashed line. And then we shade above the line because it's going to be greater than. So this should be above. Okay? Because we have to shade above the line because it's greater than. So that's a typo right there. If we have less than or equal to, since we do have equality, so we have equality here, it's going to be a solid line. And then we would shade below the line since we have less than or equal to. Okay? And the last one we have is greater than or equal to. Here we have equality because we have equal to. So we're going to draw a solid line, and then we're going to shade, again, above. So make sure you change both of those. That was a typo on my bad. So looking at this, let's look at these example 1. The solution to the x plus y equals 20 is shown on the graph below. They want us to graph the solution to x plus y is less than or equal to 20. So we know since we have equality, we're going to have a solid line. So we know since we have equality, it's going to be solid. And since it's less than, it's going to be shaded below the line. So we have our solid line already drawn for us, and we just have to shade below because we have less than. So all I'm doing is just shading the graph below. So if I picked any point within this area, shaded area, any coordinate or ordered pair x, y, anywhere on here in this area, it would be a solution to this inequality. X plus y is less than or equal to 20. Okay? And let's look at the next one. They want us to graph, well actually, I'm going to go down to this other one first. They want us to graph the solution to x plus y is greater than or equal to 20. So now we know it's going to be, since it's greater than or equal to, it will be a solid line. And since it's greater than, it will be above the line. So if we look at this, we have our solid line drawn for us already. We're going to shade above. And if I picked any point within the shaded area on the coordinate plane, or even like all the way out here, if our graph was extended, we would have a solution to this inequality. X plus y is greater than or equal to 20. Okay? So now let's move back to this graph over here. They want us to graph the solution to x plus y is less than 20. So we know since we have less than, it's going to be a dashed line since we don't have equality. And since it's less than, we're going to shade below. So what we're going to have is, if I have my ruler for some kind of straight edge, we're going to have, we know that 20, 0, 20, and 20, 0 are both, so 0, 20 and 20, 0 are both solutions. So I'm going to line my ruler up to the two 20s, and then I'm just going to draw a dashed line through them. So I'm not drawing a solid line, I'm just drawing a dashed line. Okay, and again, I can make it into a line. And then, since it's less than this line, it's not going to, this line, any solution that's on this line, is not going to be a solution to this inequality. It's anything that's just strictly below this line. Okay, so any solution that I pick that's below this line here will be a solution to that inequality. Okay, and let's look at this last example here. Graph the solution. X plus y is greater than 20. So basically, again, I know since it's greater than, it's going to be a dashed line. And since it's greater than, it will be shaded above. So it'll be dashed and above. So again, let's draw our dashed line. So we line up 20 and 20. So 0, 20 and 20, 0. And then we're going to draw our dashed line. Okay, so not a solid line. Draw a line here. And then we're going to shade above. So anything that's just strictly above this line. Not on this line, but above this line. So we can shade it however we want. So if we picked any point within this shaded area here, it would be a solution to that inequality. Okay? So now let's move on to our next example. Exercise 3 says we want to use a separate sheet of graph paper and plot the solution sets to the following equations. But we're going to look at that at a later time. I'm not going to have you guys do that right now. We might look at it in class tomorrow. So looking at this, we have half planes. A half plane is the graph of a solution set in the Cartesian coordinate plane, or just a coordinate plane, that's how we know it from, of an inequality in two real number variables that is linear and strict. A strict inequality does not include the equal to option. So it's strictly either above or below, or as it says there, strictly less than or strictly greater than. That's what we mean by a strict inequality. So, let's look at this. They want us to describe in words the half plane that is the solution to each inequality. So if we look at this, if we have y is greater than or equal to 0, well, let's just quickly just try to sketch in. So let's sketch in our xy coordinate, or xy plane, our Cartesian coordinates. So we have x and we have y. And we know that if y is greater than 0, it has to be everything above the coordinate plane. Because at the x-axis is when x is equal to 0. So it will include the x-axis, and it will include everything above the x-axis. So if we wanted to describe this half plane that is the solution to each inequality, we call it a half plane because any line right here, that it divides the whole plane in half. So there's strictly half above and half below. So let's try to describe it for this first one. The half plane, and then it's lying, the half plane that's lying above the x-axis, but it also, we can say, and includes the x-axis. And it includes the x-axis because we have that equality. So it includes that x-axis because of equality. Because we have greater than or equal to, so that's equality. So now let's look at part B. Part B says x is less than, so I'll just erase this. X is less than negative 5. So let's look at this. Let's try to sketch this one out really quick. So we have our x, y coordinate, and we want to look at the line x is equal to negative 5. And we know that that's going to be a dashed line since it's less than. So let's just say that this is about negative 5, and we're just going to sketch in our dotted line there. We know that if x is less than negative 5, it will be everything less or to the left of it. Okay? So if we look at this, because we know that if we go negative 6, negative 5, we're all going less than negative 5. That's why we shade to the left when it's a vertical line. So if we describe this half plane, it will be the half plane to the left of the vertical line x is equal to negative 5, but not including the line x is equal to negative 5. Because it doesn't include that line, that's why we had to draw a dashed line there. Okay? So now let's move on to something a little more complicated. We have y is greater than or equal to 2x minus 5. So we know that we're going to have equality, so it will include all the solutions to y is equal to 2x minus 5. And since it's greater than, it will be all of the plane that's above. So in this case, we can say the half plane lying, and since it's greater than, we're going to say above the line y is equal to 2x plus 5, and including the line. We could say y is equal to 2x plus 5. Okay? So now let's look at this one. So since we knew that this one was greater than or equal to 2x minus 5, we knew that that one was going to be 1, that it's going to be above since it's greater than, and it's going to be a solid line. So if it's solid, that means that we're going to include it. Okay? But now we have less than, and we know less than is going to be below. And since we don't have equality, it's going to be a dashed. So we're not going to include. So we're going to not include. Okay, so now let's try to write our half plane that goes along with this. It will be the half plane lying below the line y is equal to 2x minus 5, but not including the line y is equal to 2x minus 5. Okay? Alright, so that's our exercise on half planes. So now let's go on to our last example that we have here. Exercise 5. They want us to graph the solution set to x is less than negative 5, reading it as an inequality in one variable, and describe the solution set in words. Then they want us to graph x is less than negative 5 again, and this time reading it as an inequality in two variables, and describe the solution set in words. So let's first start doing in one variable. Let's describe our solution in one variable the way that we did in past lessons. So let's start with x is greater than negative 5. So let's describe the solution set in words. So in words, we can say that it's going to be all real number solutions that are less than negative 5. Okay? And then on our graph, in one variable, we're going to plot it on a number line. So we start with negative 5, so we go negative 6, negative 7, negative 8, negative 4, negative 3, negative 2. Okay, so we know that at negative 5 we're going to have an open circle because we don't have equality. And then since it's less than, we're going to go to the left. Okay, and that's going to be our solution in one variable. So now let's look at it in a two variable. So now we're going to have two variables. So let's look at x, again, is less than negative 5. So let's talk about what we just learned today. So since it's less than, we know that we're going to have a dashed line. And since it's x, we know it's going to be a vertical line. So we know we're going to have a dashed vertical line. And if we have a dashed vertical line, we're going to dash the vertical line x is equal to negative 5. Because we know that that's not included because we don't have equality up here. So we're going to have a dashed vertical line, x is equal to negative 5. So let's go through and do that. So I'm going to go through and label my graph here. So I'm just going to go up by 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, negative 10, negative 2, negative 4, negative 6, negative 8, and negative 10. So I'm going to graph the vertical line at x is equal to negative 5. So this is x is equal to negative 5. Now I'm going to draw that dashed line. So I'm going to use a ruler, line it up with x is equal to 5, and then I'm just going to draw a dashed line. So there's my dashed line. This is x is equal to negative 5. Okay? And then since I know it's going to be less than, I'm going to shade to the left. Because where's any variable of x that's less than negative 5? It would be over here to the left. So let's just shade everything to the left. Okay? And now let's try to describe the solution in words. So we have our graph now. Let's try to do our solution in words. I'm just going to zoom it out a little bit. So if we look at this, it's going to be any ordered pair that's to the left of that line. Or we can say that it will be all ordered pairs x, y, such that x is less than, x always has to be less than -5. Okay? And that is our solution set for the final equation. Okay? And that is the end of lesson 21.